Hey guys, sorry that I couldn't have the original recording, but I forgot to capture the screen. So it's just my head making noise. Not very useful for review. So I'm going to redo it again, all from the beginning. Okay. So don't worry, it'll be a quicker video for you guys and hopefully a little bit even more helpful because I just go right through it. You can always slow down, go back, but this should still be helpful. All right. Y equals AB to the X power. So this is the general formula of the equation, where A is my starting point. And remember, our starting point in mathematics, we start when x equals 0. Our B is our rate. That's how we grow or decay. And the rate is two different things. If B is bigger than 1, that is a growth. It's getting bigger if it's by 2, is doubling, doubling, doubling. If it's 3, is 3, 3, 3. And if B is less than 1, that is a decay, which means getting smaller, smaller, smaller. On a question like this with the table, you're going to do two things for me. First, you're going to tell me if it's a growth or decay. And then you're going to tell me what is the formula or the function of the situation. So first, we got to figure out if it's a growth or decay. From each number, as I go left to right, looks like I'm doing times 11. Let's say you did not realize this times 11. You could always go backwards. So 121 divided by 11. So I'm going backwards. That gives me 11, which means that must have been I multiply 11 each time. That works for any set of numbers. So I could have done 11 divided by 1 or 1 divided by 1 over 11. I would get 11. So since this is bigger than 1, I could say it's a growth. I also could say it's a growth because it's just timesing by 11. It's just getting bigger numbers. Over here, though, we also need to find the function. Remember, you need A and B to make the function. So we already found that B should be 11. We could find here that A, because 0 equals 1, that must be A. So A must be 1, B must be 11 times x. So my function's y equals 11x. Remember, because it equals 1, you don't really need to put that in front. You could just put 11x. Let's do number 2. Again, growth or decay. In this case, it's going to get bigger as I go forward. I can see 1 times blank equals 2. So it's going to be a growth. 1/8 is smaller than 1/4, so 1/4 is bigger. A quarter is bigger than smaller than a half, so it's getting bigger. A half is smaller than 1, so it's getting bigger. So it's a growth. The formula here, remember, you want to look where x equals 0. In this case, it's 1/4. So I know my A is 1/4. And my B is what I'm multiplying each time. Looks like it's times it by 2. So it's 1/4 times 1/4 times 2 to the x power. Next one, growth or decay. In this situation, as I go forward, it looks like I'm getting smaller and smaller and smaller and smaller. So that is a decay. If you ever need help finding the decay or like what the root is, so sometimes we can simply go backwards. So 5 divided by 25 equals 1 over 5. So it looks like I'm multiplying by 1 over 5 each time. So when I look for the formula or the function, it's a times b to the x. A is going to be where it equals 0, which happens to be 1 this time. And b is where it's going to be the rate or what's happening each time. It's 1 over 5x. So the answer is y equals 1 over 5x. In this one, hopefully you notice that the pattern is plus 3 each time. Because it's plus 3 each time, I cannot answer this question. It is not growth nor decay, so I cannot make the function for it. All right, when you're given a table or a graph like this, I'm going to ask you to graph it. So you're going to make x and y, and you're going to go and set up your x values. Your first step, again, is simply going to plug in -2 to 2 into the x. So -2, -1, 0, 1, 2. Some people were saying in class, do I have to put -2 to 2? You want to put 0 to 5? That's okay. It's just like you're going to have a hard time graphing it if you put it. I'm going to recommend always putting -2 to 2. Then, step 2, we're going to put it in calculator. Because why are we going to work hard to put it not to put it in the calculator? So I'm going to click y equals. I'm going to type it in as I see it's 12x. You can see the buttons turn red after I click it. So 12 to the power of, this is the button for power of above the division symbol, to the x power. Okay. Now I want to get the table. So I'm going to click second, graph, and I'll get my table. And I want to look at where it matters. So -2 is over here. So that's 0.0069. -1 was over there. So that's 0.08333. At 0, it was at 1. At 1, it's at 12. At 2, it's at 144. It's okay if these things don't fit on your graph, especially on the test. I'm going to give you a 10 by 10, mainly because these numbers get really big and really small really fast. So it makes sense that sometimes it falls off the graph. So I'm going to put the dots where they belong. 12 is over here. And I'm going to draw my shape. Your shape should not be a straight line. If it is a straight line, that's a really bad situation. So you could always use the calculator to check, because if I already have the equation, I could click just graph and it'll get me the whoop, like that. And it looks kind of like my thing. It goes this, passes the y-axis, goes straight up. Okay. Same process for any question like this. Going to put the x and the y. 1, 2, 3, 4, 5. I'll probably have a blank one for you so you can just fill it in. -2, -1, 0, 1, 2. Plug it into the calculator. I'll show you one more time. So I'm going to go y equals, clear that up. I'm going to plug in this negative. When you do a negative buttons down here, not minus sign, or you're going to get error. -3 times 2 to the power of x. We're going to go second table. And then I'm going to look at the numbers here. -0.75, -1.5, -3, -6, -12. Again, let's put the dots. -2 pi -0.7.5. So somewhere between 0 and 1. -1 comma -1.5. So somewhere between -1 and -2. 0 comma -3. 1 comma -6. Make our nice little curve like that. And then again, if you ever just worried, like, did I actually graph it right? You click the graph button, and whoop, makes the graph what you want. One more time. Over here, 2 to the times 1/5 to the x power. So we're going to plug it into the calculator. X, Y, -2, -1, 0, 1, 2. I'm not make this video too long. I'm just going to plug it in. It's going to be 2, 2/5. So that's going to be 0.4, 225. So that's going to be 0.08, 10, 50. Okay. So I'm just going to plug in these points. -2 comma 50, can't draw that. -1 comma 10, 0 comma 2, 1 comma 0.4, 2.0, 2 comma 0.8, 0.08. So give me a second. So that is for that one. Oh, and then connect the dots. All right, last one is the word problems. Israeli or not, you got to take the word problems. So A is your final amount. P is your principal amount, so that's your starting amount. R is your rate. Keep in mind that you have to change it to decimal. And T is time. So how long it does it. So for example, I buy a computer for $3,000. Depreciates means the value goes down by a rate of 20%. So I'm going to change 20% into a decimal, which is 0.2. If you're unsure how to do that, you could just do 20 divided by 100, or whatever your percent is divided by 100, and that will always give you the decimal. So 3,000 is what I start off with. So 3,000 times 1. You always use a 1. That represents one whole. Since I'm losing money, that's minus 0.2 to the t power. In the first version, it's 1 year. So I'm going to put 1 here. So 3,000 times 0.8 to the 1 year. And I just type that in the calculator. I'll go back to normal screen. Oh, if you ever need to go back to this normal screen for y equals, you click second and mode. That makes the word quit for you, okay? So 3,000 times 0.8. There's no exponent, so no need to put the exponent. So it's 2,400. So 2,400. For B, it's almost the same question. 3,000. 1 minus 0.2 to the third power. So 3,000 times 0.8 to the third power. So 3,000 times 0.8 to the power 3. 1536. So that's 1536. Last question. You're making an account that earns, so that's going up your money, 2.5%. So 2.5% equals 0.025. Again, if you're not sure, you could do 2.5 divided by 100, and that will give you 0.025. Because remember, you got to think of it 100% as 1. So 2.5 out of 100 is 0.025. You use the same formula, 500 times 1 plus 0.025 to the power of 1. So 500 times 1.025. So 500 times, how do I keep adding an extra zero? Times 1.025. That's 512.5. Because it's money, you should put 512.50 because it's cents. Okay. And if I do it for B, it's going to be 500 times 1.025 to the, since it's 5 years, to the fifth power. So 500 times 1.025 to the power of 5. 5657.04. 5657.04. Again, let your calculator do the work for you, and I hope this video helps. Sorry for the delay. I'm posting it.